Hello friends, my name is Sudhir Bin and I again welcome you all on my YouTube channel Aztec. Guys, I was little busy with my new job so I couldn't upload any video and I'm extremely sorry for that guys. But today I am making this video so that everyone can understand how to apply earthquake force in StatPro. Before going into StatPro, I will show you codal provision, that is IS 1893 code, which is for earthquake forces. In this code there are certain definition given which one should understand before applying earthquake forces in StatPro. So guys, let's start. This is a formula given in IS 1893. Is nothing but the horizontal acceleration which will hit a structure when earthquake hits a structure. So ah is given as z into I into sa by g into 2r. Here z is nothing but a zone factor which is given in table 2, and I is importance factor. Importance factor is nothing but how important a structure is, like it is hospital or it is residential building, it is firefighting building. On the basis of that, importance factors are given for different kinds of structure. And R is nothing but a response spectrum function, which for that a table is given. This R value depends on which type of structure it is, like it is ordinary moment resisting frame, whether it is special moment resisting frame. On the basis of that, we have certain factors which we should consider. I will show you the tables. This is a zone factor values. Here Z values are given for different seismic zone intensities, like we know that Mumbai falls under seismic zone 3. So for Mumbai, zone factor is 0.16. So this is about zone factor. And for SA by G we have this values which depends on the time period. This time period, for this time period calculation, we have one formula which is given in this table only. This is the formula which we have for calculation of time period. That is T is equals to 0.09. Here there is a H which is not printed in this PDF, upon square root of D. So by this formula we can calculate the time period. Then by using this time period we can have a value of SA by G. Here you can see we can put a value of T, and simply after that we can get a value of this SA by G ratio. For that, one should know that which type of soil strata is there, so that can be identified by using soil report. So since we don't have any soil report at the moment, I am considering it as a rocky soil. So by using that, if you can calculate SA by G, so we have Z SA by G, and we have importance factor also. The only thing which is remaining is here you can see importance factor for important buildings is like is 1.5, like hospitals, schools. For those buildings it is 1.5, and for all other buildings it is 1. And the only thing remaining is our response reduction factor, which we should know. Here you can see a table 7 which is given for response reduction factor R. Here different kind of frames are there. For those different kind of frames we have different R values. Like for ordinary RCC moment resisting frame value is 3, for special RC moment resisting frame value is 5. Here ordinary RCC moment resisting frame means the columns and beams are not designed for ductile detailing, but in this special RCC moment resisting frame we detail our column and beam as a ductile. So since our building is very small, so we should not detail it as a ductile detailing, as it will consume more reinforcement. So for this such a small buildings, ductile detailing is not required, so we will go with the ordinary RCC moment resisting frame, that is R is equals to 3. So I have explained guys these terms so that you can understand what are the inputs to be given in stat pro. Now let's first go to the stat model. I will use same stat model which I had used for wind load only, so that it will be easy to understand all of you. Now since this video I am making for earthquake, so I am going to delete this wind definition. Yes, and now I am going to delete this load case also related to wind. Delete, yes. Now guys, let's first define a seismic definition. So click here and click on add. Now select code. Our code is 1893 2005 2002. Okay, this is the code 1893 2002. Okay, so now either you can put values here, or you can simply click here generate. Here from either you can put Z value by selecting city or zone. If you select city, you have to select your city, or if you select zone, you will have 4 zone options, that is zone 2, zone 3, zone 4 and zone 5. These zones are mentioned in this IS code which I had shown you before. Let me show you this one more time to you, like this: zone 2, zone 3, zone 4, zone 5. And we have table also which shows different zone factor value for different cities. Like for Mumbai, we can see that this Mumbai falls under zone 3, and for zone 3 we have zone factor as 0.16. So here you can simply select either zone, city, whatever you want. I am going with city, so this is Mumbai. For that, it is automatically taking as 0.16. Now as I told you that our structure will be ordinary moment resting frame, so I am selecting this, and for that value is 3, as given in IS code also. Here you can see for ordinary RC moment resisting frame, R is equals to 3. Okay, so now we have put this value. Now importance factor, I'm considering it as a general building, so importance factor will be 1. And as I told you that I will consider a hard soil, so I am selecting here as hard soil. Then structural type, obviously our structure will be RCC frame building, so I am selecting that. Damping ratio, this damping ratio is different for RCC and steel structure. For steel structure, this value is nothing but 2%, and for RCC structure, this is 5%. This value is also mentioned in this IS code only. So let's check where it is given. This value can be seen page number 39. Here, here the value of damping for buildings may be taken as 2% and 5% of the critical for the purposes of dynamic analysis of steel and reinforced concrete building. So 2 is for steel and 5 is for RCC concrete structures. So since our building is RCC, so I am taking it as 5%. Now we have, either you can put a time by yourself or let stat to calculate it, but I will put this time period by my own calculation. So for that I have made one Excel sheet. Don't worry guys, this I will share this Excel sheet with you guys. So by using this Excel sheet I will first calculate time period which I have to put here. Then after that I will calculate AH, and then after I will calculate base shear, which we will going to cross check with stat pro values. So by doing this we can cross verify that our software, our stat pro is giving correct values. So let's proceed to calculate time period. Here guys I have put length and width and height of our building. Length of our building is 11 meter and width is 8 meter, and height of the building is 14.1 meter. Now as I shown you that Z is nothing but zone factor value. For Mumbai it is 0.16, and importance factor I am considering as 1. Then response reduction factor I am taking it as 3, and SA by G value will be 2.5. This we will calculate after calculating this time period. Okay, so first calculate this time period, this we will see after time period calculation. So for time period I had shown you one formula that T is equals to 0.09 H upon square root of B. here here is that formula. So by using this formula I had calculated this time periods for x direction and for z direction. For x direction I had taken this L value, that is length of the building. This is in x, which is in x direction. Okay, so similarly I have calculated this time for z direction, and this is nothing but T is equals to 0.09 h of height of the building upon square root of base dimension. Okay, so since after calculating this time period value we will calculate this SA by G value from the code. So in code we will see what value to be considered for SA by G. Here come since we have considered a rock hard soil, so we will see these values only. And now in this our time period is 0.38 and 0.44. So let's see, our time period is greater than 0 but it is not less than 0.1, but our time period is greater than 0.1 and less than 0.44 tx. Okay, so for tx we will take SA by G 2.5, that is 2.5, and since our time period value is 0.44 which is greater than 0.4, so for that we will take 1 by T. So for that we will take SA by G as 1 by T. So here I have taken SA by G as 1 by T for Z direction since our TZ was greater than 0.4. Okay, so I have taken this condition for z direction, and for x direction I have considered this direction, this condition. So now we have time period. Let's put this time period value in StatPro 0.382 for x direction and 0.4484 z direction. Okay guys, so now just click on generate. It will generate values here. Now there is one small problem with this stat, that this value should be, since it is percentage, so 0.05, it should be 0.05. Okay, now click on add. This self-aid factor should be 1, or you can just close it, it will consider automatically. Now we have defined seismic definition. Now just let's hide it. Now we will move to load case details. In load case detail we have already have dead and live, and which is very important, because from these loads only we will get seismic weight of the building, which will be used for seismic weight calculation. So let's add one seismic load case. Click add, select load type seismic, right here WX seismic X. Okay, now click add. Now I will add one more seismic Z. Click add. Now in seismic X, let's add a seismic load. So seismic load, here you can see a seismic load factor and direction. Since this is our seismic X, so I will select X direction and factor will be 1. So click 1, close. Then we will move to seismic Z, and here also I am going to add a seismic load. In this case I will consider this Z direction and keep this as 1, just simply add 1. Now guys, in StatPro, to apply a static earthquake force definition, earthquake load case must be a first load case. After earthquake load case, we should define dead and live load cases, otherwise it will show error. So your first load case must be earthquake load case. After that you can define other load cases. Since I had defined these load cases earlier, so I am defining earthquake after this, but I will correct it by going into stat editor, save. I will just cut and paste my earthquake load case before dead and live load case. From here onward I have load cases, loading part, not load cases. So till here. Now as you can see, this is my load definition for seismic forces, and from here onward I am having dead load type. So, and after this is first load case, this is second load case, live load, this is my third and fourth load case, which is earthquake load cases, which I must define before any other load cases. So I am pasting here and just renumber it from 1, then this is 2. Now after that other load cases will be 3, and this is 4. Okay, so this is the sequence for defining earthquake force in StatPro. First should be earthquake, then other load cases. Okay, now we have defined load cases. Now let's close it. Let's see. Yes, now it is correct. Seismic X, seismic Z, then after that dead and live. Now we have defined a seismic definition, that is here, and we have also created one load case for seismic forces. Now the only thing remaining is calculation of seismic weight. For that we should tell StatPro that these are the loads you have to consider for seismic weight of the building. So seismic weight is nothing but the dead weight of the building plus 0.25 or 0.5% of the live load. For that, first let me tell you how much percent of live load you should consider for seismic weight calculation. So guys, here you can see percentage of imposed load to be considered in seismic weight calculation. It is if your imposed load is up to 3 kilonewton per meter square, then we have to take only 25% of the live load, or if it is greater than 3 kilometer per meter square, then we have to consider 0.5% of the live load. Since in our case our live load is 3 kilometer per meter square, so we are going to consider only 25% of the live load for seismic weight calculation. So let's say stat that these are the loads you have to consider for seismic weight calculation. So for that I have to copy this dead dead load and this live load and paste it just below the earthquake definition. Now to tell stat that this is a mass source, you have to consider, for that you have to replace load by weight and load term by weight, and you have to remove this minus n gy gx terms from this mass source values. So let's remove, this is not required. This is a seismic weight, this should be only 1. No minus sign, no plus sign, no direction is required to mention here, and this load must be replaced with weight, WEIGST. Okay, now from here also I will remove minus NGY floor load. Instead of floor load it will be floor weight. Okay, then in Y range also this F load will be only positive, then this GY had to remove. Okay, then from this is our live load. Okay, and as I shown you that in live load our live load is 3, so I have to consider 0.25% of the live load. So let's remove this first as it is of no use. This is our live load part, so I have to take only 0.25% of this live load. So let's take 0.25% of this live load. Let's save it first. 0.25% of live load, that is 3 into 0.25 is nothing but 0.75. So I have to put this 0.25 value over there. And I am going to write 0.75 and remove this GY. Okay, so we have provided StatPro mass source which is to be used for seismic weight calculation. So now everything is ready with us. Now only we have to just close it. Now we have seismic definition, we have load seismic load cases. In that we have also defined mass source. Mass source comes here. These are the mass source which is to be used for seismic weight calculation. Now let's guys run this STAD model. Now let's check the results. I am going to check for seismic load cases only. Okay, so click OK. uh, I have to take base reactions to cross check whether STAD had done it properly or not. So I am copying this base reaction support reaction table to my Excel sheet. Here I have made one STAD base reactions Excel sheet. So here I will paste it. Okay. Now let's move to our Excel sheet to verify whether STAD have done it properly or not. Okay. We we had calculated till here. On the basis of this T, on these values Z, I, R, SA by G, we can calculate AH. AH is nothing but AH is equals to ZI upon 2R into SA by G. Here AH is equals to ZI upon 2R into SA by G. So AH is equals to ZI upon 2 times R D9 and into SA by G. So by this we got AH value for X direction and Z direction. Now the only thing we require is seismic weight of the building. For that we will take help of StatPro. So let's put a filter over here, apply filter. Now just consider only X direction. For seismic weight I have to take support reaction for dead and live, guys, as I had told you. So I have to do result setups. Now take dead and live load cases. Okay. Now take support reactions. These are for dead and lives. Okay. So copy it and paste it over here. We have to make one new Excel sheet. Okay. So from here we will simply add these Fy values as in StatPro. Y is vertical, so dead and live will act in vertical Y direction. So we will add this Y forces for dead and live. So let's apply here also one filter. For live dead we have to do separately. This is my dead is equals to sum of these. This is nothing but 3491. 3491. Okay, now for live load it is 756. Okay, 756. Now since our live load is 3 kilometer per meter square, so we have to consider only 0.25% of this live load, so is equals to 0.25 times this sum of live load, so is equals to this dead load plus this live load is nothing but our seismic weight of the building. Now I am going to link this in this sheet, so this is equals to this. Okay, so we got our seismic weight of the building. So now I will show one formula to calculate base shear. Our main aim was to calculate a base shear of the building, so we are one step behind to calculate base shear. So here is a formula to calculate a base shear. VB is equals to AH into W. Out of this we have calculated AH and we have calculated W also. So we have AH values for different direction and we also have a W, that is seismic weight of the building, for dead and live load case. So let's calculate a base shear for X direction. Here you have to simply multiply AH and W. So AH of X direction into seismic weight will give you base shear for X direction, and AH for Z direction into seismic weight will give you base shear in Z direction. Okay, now guys, let's see what value a STAAD have given to us. So this sheet shows STAAD base reactions, okay, which I had taken earlier. So from here you can see for seismic X I am looking for seismic X only. So this Fx forces I have to sum up, which is coming out to be 245 point, look at here guys, 245.343 kilonewton. Okay, which is exact value which I have calculated. Okay guys, so it is exactly matching 245.34. see, 245.34, it is exactly matching. And for Z, seismic Z, I have to sum up these values, 219. This value is coming out to be little less, but you can see guys, this value is 100% matching. So by doing this guys, you can verify whether STAAD is doing it correctly or not. So guys, this is the way you can check your STAAD model that it is doing correctly or not. So guys, just don't blindly follow STAAD values, you have to check whether it is giving correct values or not. So guys, this was a video to teach you how to apply a seismic force in STAAD model and how to check it, how to cross verify whether STAAD is giving correct values or not. So guys, if you like this video, please like and subscribe to my channel, and I promise I will upload more videos, and keep watching, keep learning. Thank you guys.